everyday use. This new technology has expanded our scientific aspirations. Our space probes have now visited and sent back their holiday snaps of every planet in the solar system and some of the smaller bodies. Progress has been rapid. American astronauts landed on the Moon in 1969. The Pioneer 10 spacecraft, launched in 1972, visited Jupiter and continued out of the solar system. Pioneer 11 followed it in 1973 and visited Saturn as well. In 1977, Voyager 1 and Voyager 2 set out to explore these worlds and the even more distant planets Uranus and Neptune. Other craft launched by several different nations or national groupings have visited Mercury, Venus, and Mars. Some have even landed on Venus and Mars, sending back valuable information. As I write in 2015, 5 orbital probes and 2 surface vehicles are exploring Mars. Cassini is in orbit around Saturn. The Dawn spacecraft is orbiting the former asteroid and recently promoted dwarf planet Ceres, and the New Horizons spacecraft has just whizzed past and sent back stunning images of the most famous dwarf planet in the solar system, Pluto. Its data will help resolve the mysteries of this enigmatic body and its 5 moons. It has already shown that Pluto is marginally larger than Eris, a more distant dwarf planet previously thought to be the largest. Pluto was reclassified as a dwarf planet in order to exclude Eris from planetary status. Now we discover they needn't have bothered. We're also starting to explore lesser but equally fascinating bodies: moons, asteroids, and comets. It may not be Star Trek, but the final frontier is opening up. Space exploration is basic science, and while most of us are intrigued by new discoveries about the planets, some prefer their tax contributions to produce more down-to-earth payoffs. As far as everyday life is concerned, our ability to create accurate mathematical models of bodies interacting under gravity has given the world a range of technological wonders that rely on artificial satellites. Satellite television, a highly efficient international telephone network, weather satellites, satellites watching the sun for magnetic storms, satellites keeping watch on the environment and mapping the globe, even car sat-nav using the Global Positioning System. Please pause your audiobook and refer to the photograph with the caption that reads, "On 14 July 2015, NASA's New Horizons space probe sent this historic image of Pluto to Earth, the first to show clear features on the dwarf planet." These accomplishments would have amazed previous generations. Even in the 1930s, most people thought that no human would ever stand on the moon. Today, plenty of rather naive conspiracy theorists still think nobody has, but don't get me started. There were heated arguments about even the bare possibility of spaceflight. Some people insisted that rockets wouldn't work in space because there is nothing there to push against, unaware of Newton's third law of motion. To every action, there is an equal and opposite reaction. Serious scientists stoutly insisted that a rocket would never work because you needed a lot of fuel to lift the rocket, then more fuel to lift the fuel, then more fuel to lift that, even when a picture in the 14th century Chinese Hulongjing Fire Dragon Manual by Xiao Yu depicts a fire dragon, aka multi-stage rocket. This Chinese naval weapon used discardable boosters to launch an upper stage shaped like the head of a dragon, loaded with fire arrows that shot out of its mouth. Conrad Haas made the first European experiment with multi-stage rockets in 1551. 20th century rocketry pioneers pointed out that the first stage of a multi-stage rocket would be able to lift the second stage and its fuel while dropping off all the excess weight of the now exhausted first stage. Konstantin Tsiolkovsky published detailed and realistic calculations about the exploration of the solar system in 1911. Well, we got to the moon despite the naysayers, using precisely the ideas that they were too blinkered to contemplate.